In this video, we'll talk about the seventh, Roman numeral 7 type of problems, and these are our distance equals rate times time, or our DIRT problems. A train from New York to Washington, D.C. is averaging 30 miles per hour on its journey. But on the return trip, a snowstorm causes the train to average only 20 miles per hour. If the entire trip takes 16 hours, how long does each part of the trip take, and how far is the trip from New York to DC? So we know we have two parts to this trip, so it's going to make a good choice. It's going to make using our chart a good choice here. And so we have New York to DC, and we have DC to New York, and we have distance equals rate times time. Alright, so what do we know? We do know that from New York to DC we averaged 30 miles per hour. From DC back to New York, because of the snowstorm, we averaged only 10 miles per hour. Now, what do we know about the time? We only know that the entire trip took 16 hours. So when we know the entire trip, the length or the time for the whole trip, we don't know the individual parts. We make one of the parts to be x. For example, that might be 2, it might be 4 or 5. Then to find the other part, we're simply going to subtract what we already have from the total. So if the total is 16, we're going to subtract x from that. And we're going to end up with 16 minus x. So this is an important step in this. It's not x minus 16. It's not how much you spent getting from New York or how long it took getting from New York to DC minus 16. But it's the 16 total hours minus however much of that you used up already getting from New York to DC. So then we're going to write our distance, which is simply the product of the rate times the time. So we have 30 times x and 20 times 16 minus x. Now the one thing we know about the distances is that the distances are the same for both legs of this trip here. So our equation then is simply going to set those two distances equal to each other. We're not always going to do that, but when we know that the distances are the same, we certainly can do that. So we have 30x minus 30x equals 20 times 16 minus x. And then we're going to distribute on the right side. 30x is equal to 20 times 16. 20 times 16 is 320. And minus 20x when we distribute. Don't forget that you have to distribute the 20 times both, watching out for your signs there. At this point, we're going to collect our x's on the same side. Sorry, we're adding 20. A little bit ahead of myself. I saw that when I added 20, I would get 50, and so I wrote down the 50 instead. Got to watch out for that. So 50x is equal to 320. Now we divide by 50 on both sides, and we end up with x is equal to 32 over 5. And we can use our calculator for that. Or just divide 320 by 50, and we get 6.4. So 6.4, what is 6.4? It's 6.4 hours. If we didn't know, we'd go back to our table and we'd see that the x is in the column that is time, and also for New York to DC. So what does that mean then? That is the time to travel from New York to DC. If we wanted which we do need, how long does each part of the trip take? So I can write 6.4 over here. Then to find the other, I know if the total is 16 and the New York to DC trip took 6.4, then that must mean that 16 minus x is 16 minus 6.4, which is 9.6 hours. And that is the time to travel from DC to New York in the snowstorm. All right, so we'll write the 9.6 over here. Now, the final question then is how far is the trip from New York to DC? To figure out how far it is, we simply are asking distance equals rate times time. So we know that the rate was 30 miles per hour. The time was 6.4 hours, sorry. We'll bring in the calculator. We have 6.4 there times 30 is equal to 192. Now it's a good check to make sure, since we knew that the two distances were the same, to make sure that the trip back from DC to New York also took exactly, or was also exactly 192 miles. So we had the rate was 20, and the T16 minus 6.4 is 9.6. And when we multiply those, 20 times 9.6 would get 192 miles. And so we do have the same distance, and that should be the solution to this problem. We'll go on to another example. So in number 18, we have the B&M computer train traveling from Acton to Boston at a speed of 20 miles per hour during the morning rush. The return trip to Acton in the evening takes 10 minutes or 1/6 of an hour less because the train travels 5 miles per hour faster. How long does the trip take in the morning? And how far is the ride from Acton to Boston? So again, we have a distance problem where we have two different things happening. We have the trip from Acton to Boston in the morning for commuters, and we have the trip back in the evening. So we have our distance equals rate times time. All right, so what information do we know? We know that there's a speed of 25 miles per hour during the morning rush. So let's put that in red. 25 miles per hour during the morning rush. And in the evening, it travels 5 miles per hour faster. So that would be 30. That would be 30 miles per hour. How about the time? Well, we don't know how long the time takes to get from Boston to Acton, but we do know that coming home, the time is 1/6 hour less. So here we don't know the total of the trip. We don't know the first time, but we do know that the second time is 1/6 of an hour less. So here we actually are going to use an x minus 1/6. It's 1/6 of an hour less coming back than it took going there. Now what we do know about the distances, again, are that they are the same. So if I multiply rate times time, and again rate times time, so this problem is different than the previous problem because we didn't know in this problem the total time of the trip. Instead, what we know is that the second part of the trip, the return trip, took 1/6 of an hour less than the time going. So you really have to watch out. You have to construct your equations carefully. However, we do know that the distances are the same both ways. So we're going to set up our equation to be 25x is equal to 30 times x minus 1/6. Going to distribute on the right. We get 30x And 30 times 1/6 is just 30 over 6, which is 5. So 30x minus 5. All right. So we can do this two ways. We can subtract 30x on both sides. And we get negative 5x is equal to negative 5. Dividing both sides by negative 5, we're going to get x is equal to 1. Again, looking at our table, where's the x? It's the time from Acton to Boston. So 1 hour. Sorry, we need to plug in here. All right. So once we know that, then we can figure out what the time from Boston to Acton is. So Boston to Acton is x minus 1/6, which is 1 hour minus 1/6 of an hour, which is 5/6 of an hour. We know that an hour divided by 6 is 10. And so that's really 50 minutes. But we knew that because in the problem originally it told us that the time was 10 minutes less. So we could have used that also. So 50 minutes to get back home in the evening. All right, the last question we want to know is how far is the ride from Acton to Boston? Well, distance equals rate times time. And we have 25 times 1, which is 25 miles. Coming back, distance is rate times time. We have 30 miles times 5/6 of an hour. And that's either 150 over 6, or we cross cancel to get 5 times 5, which is also 25 miles. All right, so that's going to do it for this problem.